Alright, so let's talk about the concept of binary operations. Let me try to hammer this within 5 minutes. Okay, so binary first of all means 2. So binary operations is going to be performing an operation on 2 things. Okay, so if I'm going to say A plus B, addition is an example of a binary operation. It can only be performed on 2 things. Okay, even if you're going to add 3 numbers, it's a must. You just have to do first of all start with a 2, or you can start with the other 2 and then basically get to add the result. Let's say a B plus C is Y, so you have to first of all find B plus C, and then that's when you get to find. So it's a binary operation on 2. Okay, so now what exactly is a binary operation under mathematics? When do you say something is a binary operation? So I like giving an example using this set 0 and 1, and then we can now focus on the positive, or that's the addition, the subtraction, the multiplication, and the division. Let's try to identify which ones are binary operations on this set. So for something to be a binary operation on a given set, for addition to be a binary operation on a given set, what it implies is whatever operation you're going to perform, the results should always be contained within the given set. What does that mean in action? So if we look at the two numbers we have here, does it mean if I say 0 plus 1, and I think this is the only operation we can have on two different things. Yeah, so 0 plus 1 is definitely going to be a 1, and there are not two numbers. Of course, you can't repeat, you can't add a number with itself. It's a binary operation. It's going to be on two different numbers. So every addition you're going to perform within that set is giving you a 1. So the result is within the set. So the fact that the result is within the set, it implies addition is a binary operation on that set. How about subtraction? Is it? So of course I know if I'm going to focus on 1 minus 0, it's going to be a 1. Now what if I said 0 minus 1? It's also it's still subtraction on that set, but it's giving me a negative 1. So the negative 1 is not within the set, so subtraction is disqualified. And of course, from that you can see that just because there is a single result that defends, it's not enough. What we do is instead we look for the negative aspects. Is there anything that can disqualify it? And of course there is. Now, what if we look at multiplication? 0 times 1, 1 times 0, that's a 0, that's a 0. So 0 is within the set. So multiplication in this case is a binary operation. Division, 0 divided by 1 is a 1. 1 divided by 0 is undefined. So it's definitely not a binary operation on that set. Okay? So I think I've now introduced you to the idea, to the concept of binary operations. And then let me try to make it a bit more interesting and remove a 0 and focus on 1, 2, maybe a 3. Maybe a 3. So definitely for this one, it's going to be a bit odd. Maybe let me remove a 3. Let me remove a 3. Is addition a binary operation on that set? 1 plus 2 is a 3. It's not. Is subtraction? 1 minus 2 is going to be a negative 1. Not. Multiplication 1 times 2 is a 2. 2 times 1 is a 2. So it is still a binary operation because of the possible operations you can perform will still give you an answer contained in that set. Division, 1 divided by 2 is of course 0.5, which is not in the set. Okay, so that's a basic introduction to what a binary operation is. Now, how do we apply this now in action? How do we apply this in action? So whether you see A star B, which is usually the common notation used, or you see something like this, whatever symbol we are going to use, it all means the same. In some books we can even go as far as even using a triangle, trying to give you different kinds of binary operations. So I can start with the simplest one. We can have a look at where we can say 2a minus b, and then that one, let's say maybe we can call it a squared plus b squared minus ab, and then for the x and the y, maybe let's try to call it 2x plus y, something like that. So these are examples of binary operations. Okay, now how do you simplify things like 2 star 3? Okay, what does that mean? So what that means is you have to substitute in the equation. Okay, so if you look at the first part, 2 star 3, so if you're going to write what you have, 2 star 3, you can see that a is matching up with 2, 3 is matching up with b, so it implies wherever is a you're going to put a 2. So how is that going to come out? So you're going to have wherever is a, we're going to put a 2, and then minus wherever is b, we're going to put a 3. So we're going to have 4 minus 3, which is equal to 1. That's how you perform binary operations. I know some of you have not gotten it yet. So again, if we continue pushing that, you'll still see that a is still matching up with 2, right? So if I'm going to go on the second one, feel free to pause the video and try it out. So 2 star 3, so wherever is a, I'm going to put 2. So I'm going to have 2 squared. Wherever is b, I'm going to put a 3. So 3 squared minus now ab. A is 2, b is a 3. So we have 4 plus 9 minus 6. 9 plus 4 is going to be a 13. Minus 6 is going to be a 7, I believe. So 7. So that's the result we have there. So binary operations are very simple, right? Very, very simple. So all the same, if we drop it down, you'll see that x matches up with 2. So it will be 2 times 2, and then for the y, it's a 3. So that's a 4 plus 3, that's also a 7. That's how we perform binary operations. Now, the other important concept now that I want you to really pay attention is, what if I said 2 star 3 star 1? So it can't, the question, there's no way the question can come out like that. So you are always going to either put the brackets on 2 star 3 or 3 star 1, because I said the binary operation is always supposed to be performed on 2. So the brackets dictates which one to start with. So if we're going to have 2 star 3, it means first of all, let's first of all simplify that. So I'll use the first 2 to explain this concept. So let's start with the first one. So when we have 2 star 3, it implies we're going to put 2 star 3 first of all. Since they're the ones in the brackets, we'll first of all perform a binary operation on that. So for the very first one, it implies where there is a, we're going to put a 2, and then where there is a b, we're going to put a 3. So that's going to be a 4 minus a 3, that's going to be a 1. So now in the brackets, we found a 1. So what that means is it has simplified to 1 star the one that was already there. So what that means again is we're supposed to go back again. We'll now update our results. We're now going to use 1 star 1. Now where there is a, we're definitely going to put 1s on both. So it will be 2 times 1 minus a 1. So that will be a 1. So that's the answer for the final, for the first one. How does this look for the second one? Same procedure. We have to first of all start with what's in the brackets, 2 star 3. So where there is a, we're going to put 2. So it will be 2 squared. Where there is b, we're going to put a 3. And then minus ab, so 2 times 3. 2 squared is a 4 plus 3 squared, which is a 9. 9 plus 4 is a 13. Minus a 5, which is definitely 8. So found 8. So this simplifies to what we've got in the brackets is 8. Now to be star 1. So we can now erase that and proceed now. On the next stage, we'll update our values. We'll have 8 star 1. So we have 8 squared plus 1 squared minus 8 times 1. So that would be 64 plus 1, 65 minus 8. So 64, of course, minus 8 is going to be 56 plus a 1, 57. Good, right? So that's what we have for that one. So we now know how to simplify the binary operations. Now there are questions that will ask you. The other questions you can expect under binary operations are questions like, is it commutative? Is it associative? These are the two common questions they ask. So what does that even mean? So commutativeness focuses on the idea that, is it true that for every number, if you say A star B and B star A, are they going to give you the same result? If you are going to swap A and B, are they going to give you the same result? That's what the argument is for commutativeness. So we'll start with that. So let's start with the first one. Is it commutative? Is it commutative? So we already have A star B. Let me try to find B star A. So B star A would imply, we'll take it as though the same way we're taking the numbers. So where there's A, we're going to, in short, we're swapping. So where there's A, we're going to have B. So 2B minus A. Now the question is 2A minus B equal to 2B minus A? Clearly, they're not the same. Clearly not the same. So they are not equal. So there is no way that binary operation is going to be commutative. So it's not commutative. Not commutative. Okay? Take note of that. So it's not enough just because you've tried 2 star 3 and then 3 star 2, just because they are giving you the same result and then you feel convinced. You have to try using the letters, because there are going to be numbers that are going to deny that fact. Now for the next one, what if we said B plus A? What do we expect? So we're going to have now B squared plus A squared minus BA. Now this one is a bit interesting. Is A squared plus B squared minus AB equal to B squared plus A squared minus BA? Well, let's be careful with mathematics. So let me try to arrange the right hand side in form of the first part. I know A squared plus B squared can be written as A squared plus B squared. I'm still right. I've just swapped them. And then BA can be written as AB if I want to. So you see that these are actually the same, right? So in such a case, we can say this is commutative. It doesn't matter what you start with, you still get the same result, whether you start with a B or an A. So what's the concept of commutativeness under binary operations? Now the other concept that's also essential is the concept of associativeness. Associativeness. So what should we know about associativeness? So associativeness focuses on the idea of you dealing with 3. If you're going to have A star B star C, does it matter what really you start with? If you start with B star C, or you decide to start with the first part A star B and then star C, does it affect the result? If it's going to be the same, if they're going to be the same, then you're going to conclude, of course, it's going to be associative. That's associativeness. So let me try to let's try to test for the 2 we have to help us understand how we test associativeness. So for A star B we already have it. So of course we are supposed to try if A star B and then star C is going to be equal to A and then star B star C. Does it matter what you really start with? So we already have A star B, it's equal to that. So let's try to find A star B star C. So A star B star C. So A star B, don't forget it's equal to that. So that is equal to 2A minus B. Okay, so that's what we're having. Now star C. What does that really mean? So what that really means is we are still substituting in that very binary operation. So it's like where there's A, we're going to put 2A minus B, and then where there's B, we're going to put a C. So where there's A, let's put 2A minus B. So put 2A minus B, and then where there's B, we're going to put a C since they are matching like this. So C, we're going to put on B. Okay, so that's what we have for that part. So we found A star B star C. It's 2A minus B minus C. Let's move on. Let's try to find now, for the other part, we're supposed to find B star C as the first one. So let's find it. So B star C in the same binary operation, it means where there's A, we're going to put a B, where there's B, we're going to put a C. So don't forget that's an A. That's an A. So we're going to have 2B minus C. Now we can straight away find A star B star C. Now where is B star C? Don't forget that we found 2B minus C. So that's 2B minus C. So if we're going to find A star B star C, B star C is 2B minus C. So if we're going to go back to that same binary operation, it means where there's A, we're going to put A. Where there's B, we're going to put 2B minus C. So where there's A, it will remain A. Where there's B, we're going to put 2B minus C. So we found both the left and the right hand side. We can simplify them so that we see. So 2A minus 2B plus a C. For that one is going to be 4A minus 2B minus C. Now the question is that part equal to this part? Clearly not. So we can see that it's not associative since they're not equal. Now let's try to apply the same concept to this next one. Let's try to apply the same concept to this next one. Okay, so for simplicity's sake, I can put a star there since I don't want to edit the other side. Well, it doesn't matter anyway. So let's start with the left hand side. Left hand side we have A star B star C, right? Now we already have A star B in the question, so we can go straight. So A star B star C. So for A star B star C, or A star B, this one, this part, it's equal to that. So that is equal to A squared plus B squared minus AB. Now we're trying to find that with star C. So it means where there's A, we're going to put this. Where there's B, we're going to put C, since that's where they're matching up. This is matching up with that, and then this is matching up with B. So let's go on. Let's see what we can have now. So where there's A, we're going to put this. So we're going to have A squared plus B squared minus AB squared. Where there's B, we're going to put C, so it will be C squared, and then minus AB. So A is again this. Now B is C, so we're going to put first of all C, and then I'll put A in the brackets. A squared plus B squared minus AB. Okay, so for the sake of simplicity, let me try to leave it there for now. And then for the other one, what we have is A star B and then star C. So let's try to find first of all B star C since we don't have it. So B star C is going to be B star C. So where there's A, we're going to have a B in that. So we're going to have B squared plus C squared minus BC. We found B star C. Now we have to find A star this. So where there's A, it will remain an A. So we're going to have A squared. Now where there's B, we're going to have b squared plus c squared minus bc. So what is squared? And then we have minus ab. So our a remains a, and then our b is b squared plus c squared minus bc. Now the question at hand is, are these two going to be the same? Are they the same? That's the argument we have here. Are they the same? So let's try to observe. We can actually try to go beyond and just try to simplify what we have and ultimately see the outcome. Okay? So if I'm going to look at the first part, clearly, this part, where can I see that being duplicated? I don't see it duplicated anywhere. Where can I see c squared duplicated in the result? I don't see it anywhere. Where can I see that duplicated again? I can't see it. So I think these are not the same. You can try simplifying, maybe you may find a different answer, but I don't think they're the same. So the idea anyway is that for associativeness, the results should be the same if you're going to perform the A star B star C. Okay? So this is just a short video that I just wanted to introduce you to binary operations, and of course there are many more practice questions that I've answered on this topic that you can actually get to watch and deepen your understanding of the topic. So thank you very much for taking time to watch. I hope this was a quick recap and a quick just dive into binary operations within a single video.